Okay, all that today's video is going to do is teach you how to tell the difference between a linear function, a quadratic function, and an exponential function. That's all that we're going to be doing today. This standard says distinguish between situations that can be modeled with linear functions and with exponential functions. Now, we have three functions. Your freshman year of math, we have linear, quadratic, and exponential, and I have no idea why that's not here, the word quadratic in the standard, but it ought to be, because they are going to expect you to know that, because we have all three of them. Now, I'm going to start by explaining to you that linear functions grow by equal differences over equal intervals, meaning that I am either going to add the same number or subtract the same number with each part of the table, with the y's. Exponential functions grow by equal factors, meaning I'm going to multiply by the same thing over equal intervals. And this can be shown with an algebraic proof, with a table showing the differences, or by calculating average rates of change over equal intervals. All right. Then it says observe using graphs and tables. We are going to be looking at graphs. We're going to be looking at tables. We're going to be looking at equations today. Observe using graphs and tables that a quantity increasing exponentially, meaning that you have x as an exponent, will eventually exceed a quantity increasing linearly, quadratically, or more generally as a polynomial function. An exponential function will eventually overtake all the others. That's because it's the boss. It just is. Okay. Now, it isn't necessarily going to overtake them in every interval. That won't happen in every interval, depending on what. But eventually, in the graph, it will exceed and overtake them. All right. A linear function. You've been doing a linear function for quite some time. This is a linear equation right here. If you'll notice what it looks like, you've got 3x. X is on the ground, so to speak, and I'll explain that later. Later on, you're going to have an x as an exponent, and it'll be up in the air. But this one looks like this. You come over, you graph that function. I'm not going to go in about how to graph that function right here, because you know it forms a line when it's linear. Okay, it has a constant rate of change in the table. So here's the table, starting from -1 and going to 1. These are the values that I get when I plug in -2. 3 times -2 is -6, plus 2 is -4. That's how I'm getting each of these values. So this is your table. If you notice, to go from -4 to -1, I'm adding 3. To go from -1 to 2, I'm adding 3. To go from 2 to 5, I'm adding 3. A linear function has a constant rate of change over the intervals. So I'm adding 3 each time. A quadratic function, and I've got several of them drawn here from when I taught class today, but this equation, this is the graph, and I didn't draw it exactly right, but this is the graph right here. It is U-shaped. A quadratic equation will have a U-shape. It doesn't always do this right here on the y-axis. That's why I drew these over here. Sometimes it's stretched out like this one. Sometimes it's flipped upside down like this one, but it is U-shaped, a quadratic function. Also, you will have an exponent of 2. So that's how you know the biggest exponent will be an exponent of 2. All right. The table has a constant rate of change in the change. All right, here's the table. If I put -1 into this graph, into this, I would get 7. If I put 0 into this, I would get 4. If I put 1 into that equation, I would get 5. And if I put 2, I would get 10. Now, if you look at the change here, to go from 7 to 4, I subtracted 3. To go from 4 to 5, I added 1. To go from 5 to 10, I added 5. Nothing is the same here. It's not linear. If I come over here, though, and I do the change of the change, to go from -3 to 1, I add 4. To go from 1 to 5, I add 4. If I had done the point 3 and come over here, it would have done the same thing. This would have probably been 9 right here. So that means that 3, it's 19. this would have been 9, and to go from 5 to 9, I would have added 4. So the change of the change is constant. That's quadratic. That's how you can tell when all you have is a table. An exponential function, the exponent will be x. It will be your variable. It's up in the air. Now, when I graph this one, and let's get rid of these green graphs so that it makes sense to you. When I graph this function and I put in -2 as an exponent, 3 to the -2 power is 1/9, 3 to the -1 power is 1/3, 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9. This is my table. So I'm going to come over, I'm going to graph this graph. At -2, it's 1/9. Just estimate. At -1, it's 1/3. At 0, it's 1. At 1, it was 3. And at 2, it was 9. You see, an exponential function takes off really, really fast. It goes up really, really fast. If I were to do 3 to the 3rd, it would be at 27, way on up here. All right. So that's what an exponential function looks like. It's kind of an L shape with a curve. Now, the one I graphed just now, it goes like this. Others will do exactly the opposite and go like this. Others, which is why I had those green graphs earlier, others will flip upside down and go like this. And some of them will even cross. I haven't crossed the x-axis yet, but some might even cross the x-axis. It's not that they can't, but they're L-shaped. Okay, that's how you're going to recognize an exponential function. Now, an exponential function will also have a constant ratio, meaning that I will multiply by the same thing. With linear, I added the same thing or subtracted the same thing. I'm going to multiply or divide by the same thing on exponential. So, and you may not see it with the fractions. Come down here and look. 1 to 3, I multiplied by 3. 3 to 9, I multiplied by 3. All right, so 1/3 times 3 gives me 1, and 1/9 times 3 gives me 1/3. If you can't find it, what you can do, if you don't know in your head what it is, you can take 9, divide it by 3, and it will tell you that you're multiplying by 3. So if you take this and divide it by that, it'll tell you what you're multiplying by. I could take 1/3 and divide it by 1/9, and it would tell me that I was multiplying by 3. So you can find it. So remember, this is the difference. A linear function looks like this. There is no exponent. It has an understood exponent of 1. X is down here. The table, you add the same number, and the graph is linear shaped. It looks like a line. Quadratic is U-shaped. You have an exponent of 2. That's your highest exponent. And then you'll add the same thing coming down. You won't get the same thing. You'll add and see that they're different. Then you'll try it again. And if you get the same thing here, it's quadratic. So the change of the change is the same. Exponential multiplies by the same thing. The exponent is the x. And then it's L-shaped with a curve in there. It's not got a point for the L. So remember all that. An exponential function is a function that forms a curve that always increases or always decreases and has a constant ratio. So it's either going up or going down. A linear function forms a straight line and has a constant rate of change. You're adding the same thing or subtracting the same thing. Quadratic function forms a parabola or is U-shaped when graphed and has a constant rate of change in the change. Remember, the second change will be the same. Thank you.